Okay, so on to another area. So now that we have ways to know things exist, sometimes we look for ways to figure out the solution without maybe solving it. And this slope field is kind of a way. So remember, first order differential equation or differential equation of the highest order of y prime. This is the differential equation of y prime where it's a function of y and t. And remember, derivatives represent rates of change, and graphically that's the slope. What I'd like to do is show that given any initial point, we can find slopes and draw those on the thing. So here's an example. This is a rate in, rate out question, and we've actually seen it before. We'll take off this part. But remember, there's 60,000 fish, and the population grows continuously over by 20% each year with 10,000. So if F represents fish in 1,000, T time in years, then we would have dF dt equals 0.2 F minus, because we're harvesting those fish, 10. And so what I'd like to do is do a slope field, and we're only going to be positive in this case because fish and time will be positive. It doesn't necessarily, time doesn't have to be positive, it's just where we start counting, right? And so let's just see what these values are. So if, let's pick some values for F, let's say it's 10, 20, 30. And then we'll just pick, we're just going to pick a couple points here. So let's pick the point. So this is T and F. Let's pick 10 and 2 and 20 and 3. Doesn't really have to be in any order. Oh, I wrote this the wrong way. I want my time to be 2, my fish to be 10, my time to be 3, my fish to be 20, and I'll say time is 1, and fish is 30. So these are just 3 points that I want to find the slope for. Okay. And also let's do time is 0 and 5. Okay. So we have 1, 2, 3. So 210. So that point for 210 is 210. This is the point. And if I plug this into here, so we know dF dt is 0.2 times 10 minus 10. And 10 times 0.2, maybe I don't want to do 5, is just 2. So this is 2 minus 10. So this means my rate of change is -8. So that's a slope that's negative. And 8 is pretty darn steep. So actually, I wanted to make this 50 here. That's the other point I want to do. Okay, 210, now 320. So 320 is here. And if I want to plug in the slope here, so I'm just plugging in and finding the slope. So this is the location on the graph, and then I'm drawing a little slope here. So the slope here was -8. That's the slope there. So now at 320, there's my point that I'm interested in. If I plug it in to the differential equation, this is the differential equation I'm plugging it in. I only have to plug in the fish. So 20 times 2 is 4, and this equals -6. So it is also negative. Let's make this 50, let's make this 60. And let's make, sorry, I'm changing my points, 160. So let's do 0, 50. So dF dt, I'm just plugging into the differential equation to find my slope at this point. So 0, 50 is right here, that's my point. But I don't know which way to make my arrow because these have been pointing down because they're negative. And now I'm interested in 0, 50. I just chose these points at random, plug in 50. 50 times 2 is 10, minus 10 is 0. And so that's a slope of 0. That means it's flat right here. Here's my slope right there. And then one more that I decided to do, 60. And this is minus 10. So 12 minus 10 is 2. Now it's positive, so it's 60. Oh, I said 160, so that's this point. And then now it's positive. It's pretty flat though. Okay, so this is the idea of a slope field, is that a direction field, sorry. I guess they're both are correct. Is that I pick points in the field and then I can draw all these arrows showing where they are, how the thing changes. And in fact, because t was not in this function, I know it doesn't really matter what t I pick, that really I could fill this in here and know that I have, for all t's, because it wasn't changing with t, that I have something like this at those points. And so depending on where I'm starting, I didn't do this point, but it's negative. It'll be negative. Just know that I just know this. And so if I started at some point, I could imagine I'm following these arrows and then I get steeper and steeper. And so this would give me sort of my direction. If I started here, I actually would just end up going flat. If I started like here, I'd end up going up. Okay, so we're going to do more of these in a bit. So don't worry if this was confusing.